Today we're going to talk about integers and graphing. So here's our problem of the day. Up and downs of shopping. Daniel is shopping at Macy's with many floors. He enters the store on the middle floor from a skyway and he immediately goes to the credit department. After making sure his credit is good, he goes up 3 floors to the housewares department. Then he goes down 5 floors to the children's department. Then he goes up 6 floors to the TV department. Finally, he goes down 10 floors to the main entrance of the store, which is on the first floor and leaves to go to Dillard's down the street. How many floors does Macy's have? Show your drawing. So let's draw this. Here's the building. I don't know if you've ever been to downtown or the Texas Medical Center. If you go to downtown or the Texas Medical Center, you have different skyscraper or high rises. And in order to facilitate easy movement between the towers, architects have built something called skyways that are air conditioned. So when it rains, it prevents people from getting from doing the weather element, for experiencing the weather condition outside. So Daniel enters the middle floor from a skyway and he immediately goes to the credit department. So this is the credit department. This floor is where you get credit. After making sure his credit is good, he goes up 3 floors to the houseware department. So he goes up 1, he goes up 2, he goes up 3. Do you notice how I counted the next floor? So it goes up 1, 2, 3, up 3 floors to the houseware department. I'm going to abbreviate it with HW. Then he goes down 5 floors. He goes down 5 floors to the children's department. So we're at the houseware. We go down 1, 2, 3, 4, and 5. So this is the children's department. Then he goes back up 6 floors to the TV department. So right now he's in the children's department. He goes up next floor 1, 2, 3, 4, 5, 6. So here's the TV department. But then he goes down 10 floors to the main entrance of the store, which is on the first floor and leaves to go to Dillard's right here down the street. So I'm at the TV department. Let's go down 10 floors. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the door, the entrance way. A revolving door. So how many floors does Macy have? Let's count. Floor 1, floor 2, floor 3, floor 4, floor 5, floor 6, floor 7. Floor 8, floor 9, 10, 11. So are there 11 floors? Did you come up with 11? Not so quite. That is not correct. Let's think about it. If the credit department is in the middle of the building and there are 6 floors below it, how many floors will be above the middle floor? 6 floors. Plus the middle floor, which holds the credit and which is the skyway. So the answer to this, there are 13 floors. Macy has 13 floors. So I know some of you may have just counted the number of floors you drew, but you did not read or understand that the middle floor, that means you need to have 2 more floors there. So there's 6 floors below the credit department and 6 floors above. So why did we go over this? Well, today we're going to talk about integers. Before we talk about it, let's talk about whole numbers. What are whole numbers? Whole numbers are numbers 0, 1, 2, 3, 4, 5. As you notice, there are no fractions, there are no decimal. This is not a rational number. There are no fractions and there's no decimals here. So looking at this number line, it's 0, 1, 2, 3, 4. What can you tell me about this? The numbers are all positive. So they're positive whole numbers. Integers are like whole numbers, but they also include negative numbers. The opposite, but still no fractions and decimals are allowed. So again, from here to here are whole numbers, from 0 to 10. The opposite is on the other side. These are the negative whole numbers. So we have positive whole numbers, we have negative whole numbers. 0 is neither positive nor negative. So integers can be negative, like negative 1, negative 2, negative 3, negative 4, negative 5. And it could be positive, 1, 2, 3, 4, 5, or 0. So positive, negative. Is positive 2 the same as just 2? It is. We do not put the positive sign in front of a whole number because we know it's just a whole number, but it is positive. So this is a number line. List examples of whole numbers. Can you list examples of whole numbers? Whole numbers. 11. Positive. 18. Positive. 24. Is that a whole number? Yes. 3.7. Is that a whole number? Can you use your fingers to come up with this? 1, 2, 3. Nope. But if I took away the 7/10, it would be a positive. Is this an example of a whole number? 12. Is that an example of a whole number? Yes, it is. Because what's 12 divided by 4? 3. And let's do another example. Example of a whole number. What about 24 over 1? Is that an example of a whole number? 24 divided by 1 is 24. List examples of integers. Negative 11. Negative 2. Is 0 an integer? Yes, it is. Positive is a whole number and its opposite. 7. 8. So we have negative whole numbers, 0. We have positive whole numbers. Can we represent these? Can we put these on this diagram? Classify these numbers. So our whole numbers are 11. Let's use 11. 11 is a whole number. Can 11 also be an integer? Yes, it can. Because an integer are positive and negative whole numbers. 18. Is 18 a whole number? Yes, but it's also, is 18 an integer? It is also an integer. Positive or negative whole number. Let's try, let's go back. What about 12 over 4? Is this a whole number? Yes. 12 divided by 4 is 3. Can it also be an integer? Yes, it can. So an integer is a positive or negative whole number, including 0. What about negative 6? Is negative 6 a whole number? Nope. But can it be an integer? Yes, it can be. It can be an integer. Integer. Positive whole numbers, negative whole numbers, including 0. What about 13? If 13 is an integer, can it also be a whole number? Yes, it can, because a whole number is 0, 1, 2, 3, 4, 5, 6, 7. Positive whole numbers. 0 and positive whole numbers. And an integer, positive and negative whole numbers, including 0. What about negative 1? Can it be represented anywhere? Can it also be a whole number? Can negative 1 be? No, it cannot be. So there are two types of number lines. So again, we have a horizontal number line right here. It goes from negative 10 all the way to positive 10, we have 0. 0 is neither positive or negative. Then we have a vertical number line. Like 0 is right here, neither positive or negative. It goes up. Numbers above 0 are positive, and it goes below. Numbers below 0 are negative. Are there different words or situations where you explain something and it can be represented as an integer, a positive or negative whole number? For example, if I gain 5 pounds, which I did over the summer, how would you represent I gained 5 pounds? Gain, positive, 5. So that is a positive integers. What's the opposite of gaining 5 pounds? I lost 5 pounds. That'd be negative 5. So let's go back to our vertical number line. Imagine that this is a scale. I'm standing at 0. And then I got on a scale, I gained 5 pounds. And then, so that's my set weight. And then later on, I lost the 5 pounds. So it went back to negative. So now I'm back to 0. So let's see. Also could be football. I gained 3 yards. I lost 8 yards. It is above. It is 60 feet above sea level. Would that be represented as a positive or negative integer? We represent it as a positive integer. Is 60 a whole number also? Yes, it is. It's a whole number and an integer. So what's an opposite of it? 60 feet below sea level. Would be negative 60. So looking at the vertical number line, if it's 60 feet below, it'd be down here. If it's 60 feet above, it'd be up here. What's another one could we use? 7 years ago. 7 years ago. Would that be positive or would that be negative? Let's look at my horizontal number line. Here's 0, 7 years ago. I'm going backward, negative 7. I can represent it as negative 7. What about deposit? I deposited $8 into my checking account. Deposited $8. So I have my balance and I deposited. The word deposit, if you go into a banking, is a transaction where you put money into your banking. So it would be positive 8. Do you know the opposite of the word deposit? Withdrawal. So this one would be, I withdrew $100 from the ATM machine. I put in my ATM card, entered in my 4-digit PIN number code, and I withdrew $100. So I have my balance, and look here, I have my balance, and I withdrew $100, took out. I would represent it as a negative integer. There are many, many others that represents an integer. So so quickly looking here, find the integers. Integers are positive whole numbers or negative whole number. Integer, integer, integer. Negative whole number, negative whole number. Those 5 represents positive or negative whole numbers. Fraction, 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 decimal, decimal. But this fraction is simplified to 4/9. However, what if I had this one? 18 over 2. Would that be an integer? Yes, it is, because it can also be represented as 9 over 1 or 9. I divided the numerator and denominator by 9, or by 2 I mean, and get 9 1, which is the same as 9 whole. So again, here in a number line, if you're given a number line, could you represent it? So starting here, 0. To the right are the positive whole numbers, 1, 2, 3, 4, 5. If you want to denote it with a positive sign in front of it, you may. To the left of 0 is negative, negative 1, negative 2, negative 3, negative 4, negative 5. And here are different words. Fall, if you fall, that means negative. Rise means positive. Less means negative. Spend means negative. Less than means negative, and so on. So today what we're talking about was integers and graphing. A whole number is numbers are start at 0, 1, 2, 3, 4, 5, 6, 7, 8. No decimals. A integer positive is a whole number and its opposite. So we have a or another way to represent it is positive whole numbers, 0, negative whole numbers. And there are certain key words that denote if a number is either going to be positive, be a positive whole number or a negative whole number, or a positive integer or a negative integer.